I know that some of you are still not feeling confident with how do you draw an appropriate conclusion when you're given a geometric figure and you're given some kind of information about it. So I'm going to hopefully clarify a little bit here. And I'd say that a lot of you have some really good ideas, but you're actually being too creative with your answers. So I'm going to say use the given information, and you're going to feel like you're almost cheating because you're just taking that and you're saying, okay, I know what, in this case, the word bisects means. If this were a conditional statement, my given is my if. I'm not making up the hypothesis. The hypothesis is, what if we know that FJ bisects AC? So FJ is bisecting segment AC, and AC in this picture is, find it, right here. So here's my segment that's being bisected, and you're saying, what do I know is true? And that becomes your statement. What conclusion can I make to follow that given? And to me, the word bisects means that two things are equal. It's cut in half. So I'm finding AC. AC is cut in half. I know nothing else about anything else in that picture, so I'm ignoring everything else. I know I have vertical angles there, and some of you are going to be staring at those. I am just looking at that segment AC, and I'm looking at where FJ cuts through it, which is at point H, and I'm saying, okay, from H to A and from H to C have to be congruent segments. Now, if you were thinking that H was the midpoint of AC, that's a really good conclusion too, because sometimes when we write the definition of bisects, we write it as it's a segment that cuts another segment at its midpoint. Okay, because we like to work with equations, I'm going to allow you to go ahead and jump to the equation unless you want to put that step and then use the definition of midpoint. So I'm going to allow you to go ahead and say AH equals HC. And your reason is that you're using the definition of, we shouldn't say midpoint, we should say bisects or segment bisector. Would be even more specific. And you don't need to explain it to me. Some of you are giving me really nice paragraph explanations. We've agreed on what our definitions are, so we can just use that. Now, another possible answer is you could have had AC is congruent to HC, and then we would have written it with congruent marks and talking about the segments themselves. Okay, that's a minor detail, but I would like you to practice one of the two ways and not mix them up in terms of when you're using the equal sign and when you're using the congruent symbol. Let's try another one and see how you do. So that would be bisects. That would also work for the word midpoint. I do want to point out before I move on, that if we were bisecting an angle here, we would be making a statement about angles being congruent rather than, or equal, rather than segments. Okay, so that'd be a variation. This one's considerably different because I'm given a congruent statement. And this one might make you kind of wonder, like, what are you supposed to do here? And again, you're trying to make the most specific conclusion you can. Your given is the hypothesis. If we know this is true, then what conclusion can we make? And I'm looking for you to make a statement. 90% of the time, our statement will be an equation. Okay, but this time, I'm given an equation. So, I don't know. Let's see what we can do with it. Angle DAE. I'm going to go ahead and find that angle in my picture. And then I've got angle CAE. And if I had scissors right now, I would cut out the rest of that picture because I'm not worried about it. I'm not looking at angle 3. It doesn't even exist. I'm just looking at this part of my picture and everything to the left of it. And I do know that I have two congruent angles. So let's mark those. So a couple things we could say. If you're thinking based on the distinction I just made, some of you are going to be thinking that you know that the measure of angle DAE is equal to the measure of angle CAE. And I would take that as a very good statement. We changed from congruence to equality, and we used a definition there. Look at your definition sheet, see if you can figure out which definition we just used. Trying to use the congruent symbol there. Definition of congruent angles is what you should be seeing. Oops. So that's one possible option of what you could have put. Okay? There's a few other ones. So I was going to move that, and it doesn't look like it's going to let me. So I'm going to go ahead and erase that so we can look at something else. But that's one possible thing that we could have said. Oh, apparently it doesn't want me to erase it. Okay, so what else could I say here? Another thing that I could say is I could say actually that angle 1 is congruent to angle 2. And when we say that, 1 is really the same as angle DAE and 2 is the same as CAE. I just use numbers to make things a little easier. So I would say that statement's really not getting us anywhere. We could say that we use the substitution property, but I don't know, in terms of what we're trying to get to, I don't think it's going to get me anywhere as far as being able to say anything different or profound. So not too helpful, but I would be okay with you stating it. So there's one other thing that I'd like to point out here, and that would be that there's something we know about AE. If we know that those two angles are congruent, we have a name for this in geometry. What do we call this ray or segment AE that's coming from my vertex? Hopefully you're thinking that that's an angle bisector, because in terms of my big angle DAC, which I never named, but is the angle that is made up of those two, that is going right in the middle since my other angles are congruent. So a very good a very good conclusion that we could make is if we know the angles are congruent, then AE bisects or is a bisector of angle DAC or angle CAD. And then my reason would be different. It wouldn't be definition of congruent angles. It would be definition of angle bisector. I'm using this part with it. So there's another possible statement and reason. Okay, notice how I'm using specific. I'm not talking about angles adding up to 180 degrees because I know those two angles would add up to 180 degrees. I'm not talking about adding segment lengths here, even though I know I could. Those are all other things that we can say, but we're trying to focus on what can I draw from a given statement to sort of be the most specific I can. This is a quick one. If I know I have a midpoint, something should definitely be going off in bells and whistles in your mind right now. Midpoint equal. I'm doing this in my mind. I'm marking, and I'm actually going to do it on the picture. And we know for sure AD is equal to DC, and the reason is definition of midpoint. I know I didn't give you much time to think there, but that should be that quick. Okay? And again, we could have done this and done the congruent symbol. I'd be fine with that as well. Okay, so let's look at this one real quick, and let's go with, actually, give me 1 second. I might find another one. Sorry, I'm taking you around the bush. Yeah, let's go one more. Let's go right here. And if I'm looking at number 11, well, I've got a few things I can say. This one is very much less specific, and sometimes that's going to happen. We're not going to have given information. We're not going to have it stated. So now I do have to be a little bit more creative. So I first have to decide, am I going to say something about angles or about segments? And maybe it's easier to start with segments here. If I'm going to say something about segments, I've got AC, I've got B is on there, so I technically have an AB and a BC, and then I have BD. Let's focus on this one for a minute, AC. And do we know, my question would be, do we know that B is the midpoint? Because, hey, I just did that, and I could say AB is equal to BC. But in this case, it's an automatic no. It's not stated, and it's not marked with tick marks. So you don't know it, and therefore we can't say they're equal. So I could talk about segments adding up to be something else. We did this in chapter 1, except we did it in the form of this was 3x, and this was 2x, plus 7, and then the whole thing was 84, and we made an equation that said 3x plus 2x plus 7 equals 84. You did that exact problem when we were in chapter 1. We just didn't, it looked better to us because we were just doing algebra, but you were really using geometry to make that equation. And now we're just going a little bit more abstract, and we're saying, hey, I don't really care about the algebra, I just want to talk about the equation. And your reason for that is your segment addition postulate. You got to get used to seeing that one, as well as the angle addition postulate. So by segment addition postulate, I can say that the two parts add up to the whole length there. Okay, that's like one that you can always say. So if you run out of things to say, try that. Okay, but kind of use it as a last resort. And in this one, I could do the same thing with angles. So that's the other thing I'm going to do is I'm going to say, well, could I actually say that about angles? So just to give ourselves some workspace, let's see what we can say about angles. And I do have two angles in this picture. And I could say that this angle and that angle don't look equal, certainly. And even if I wanted to say they were equal, if they're not marked and I'm not told, I really shouldn't say that. So I'm going to say that I know that the measure of angle ABD, notice I'm using a little m in front because I'm talking about their measures, and the measure of angle CBD equals something. They definitely make a big angle, and I'm going to write it this way first. Measure of angle ABC, because if I'm using my angle addition postulate, I can always say that the sum of two smaller angles equals the larger angle. Okay, now, if you want to be a little bit more specific in this case, if you were thinking 180 degrees, I would agree with you. But then technically, instead of using this, we should be using a definition. What definition allows you to say those two angles definitely add up to 180 degrees? Be careful, there's two of them that could possibly work, but there's a better. The better is linear pair. Supplementary sometimes make a line, but sometimes they don't because they don't have to be adjacent. So linear pair would be your best definition to use if you're supporting the statement that the two angles add up to 180 degrees. Okay, I hope that helps. Give you a few more examples. So if you're still struggling, go back and try numbers 12 through 15 and see if you can get those right, okay?